As we continue on into scientific revolution, this lecture is going to be covering physics, scientific method, and focusing on religion. A few things I want to direct your attention once again is think about the impact. That's the main key word. In every revolution, what is the, not just the what, right, but what is the actual result? What is the effects of the scientific revolution, specifically upon society in an intellectual way, and also to the religious beliefs, which we'll cover today as well. Okay. In class, we watched a video on Galileo. Just to go into detail and some background about him is that he's really known for developing the laws of motion, and he would examine a few different elements of his experiments. So he would look at the air resistance, if that would make an impact on the way things moved. He would look at friction. He would look at force and velocity. So a lot of physics things, when you guys take physics, eventually you'll kind of understand more, how to calculate a lot of these different elements. Okay, so in the video, as you saw, he went through many different types of experiments. He did one acceleration experiment that wanted to test to see if gravity would change depending upon a weight of something, right? And so he established that gravity was a universal force that had a uniform acceleration, and one of his experiments was to drop those different pound balls, 10-pound ball, 1-pound ball, off of the Leaning Tower of Pisa in 1591. Okay, and he determined that all falling objects descend at an equal velocity regardless of their weight, and also he established the law of inertia. So inertia is that an object that is already in motion will remain continuing to move unless it is stopped by an outside force. So that is going to be used later on and built upon by Newton. Okay. All right. So a couple of inventions he came up with. 1593, he invents an early thermometer. He finds a way to calculate temperature and pressure, which is, that's kind of cool, right? But the main invention that you look at is 1609, where he builds his own telescope. He saw that the moon, through his makeshift telescope, was more of a rough and a mountainous type of surface and texture. We kind of saw that in the video as he was kind of sketching the surface of the moon, and he felt that the moon's surface is very similar to what the Earth is made of, and so he would record a lot of his observations in his book called The Starry Messenger. And whatever he saw through the telescope, whether it's the moon or the sun or the stars or the moons of Jupiter, he would record all those things and even discover the Milky Way. Okay, through his observations in through his telescope, he was able to validate Copernicus's heliocentric view, and he determined that the telescope confirmed that the moon and other planets were not perfectly round, like a sphere, but they were just kind of a general circular substance. Okay. He just calls it a body in itself because sometimes it's not spherical. And the telescope that he used was the first one used as a scientific instrument that he built. That's okay. And so his next book that he wrote was the Dialogue on the Two Chief World Systems. So he's comparing and contrasting the Ptolemaic and the Copernican view, the geocentric versus the heliocentric, and he dedicated this book to the Medici family. After writing this book, it was reviewed by the Catholic Church, and of course, they were very unhappy with it. Okay, because the contents written in the book, he believed that the Earth was a heavenly body in the sense where it would revolve around the sun, but because it lost its significance to be geocentric, right, the difference between heaven and earth no longer really held the same type of uniqueness and significance, and basically the earth was insignificant compared to this infinite world in space. Okay, so this book is going to be placed upon the Index of Forbidden Books. If you guys remember, that's part of the Roman Inquisition during the Wars of Religion, during the Roman Reformation, the Catholic Reformation. And being on the Index of Books means that basically your views are banned, and so this really overturned a lot of people's views on theology and philosophy before him. And he, at that point, is going to be condemned and forced to recant by the Catholic Church. Many other people were afraid to support Galileo because they didn't want to be associated with him. Okay, and so what a few differences of what Galileo did to build off of what Kepler's observations was that Kepler was a mathematician where he derived laws to describe the movement of planets, where Galileo, he had his own calculations and equations where he wanted to calculate the movement of the bodies on Earth, so basically objects that exist, and that's how kind of gravity plays into it. Okay, all right, so a couple of images. The top left one, this is Galileo facing the Roman Inquisition, as with the title slide. The bottom is the first replica of one of his telescopes, and on the far right is the Cathedral of Pisa with the pendulum. If you remember, the video mentioned that the pendulum was indicated that it always swings an equal distance and was able to help calculate time. Okay, all right, so Newton comes about a century later, but he's just as important, if not more important, than Galileo. And last year on the AP test, there was a question on Newtonian physics. So you don't need to know exactly the in and outs, but you just need to know the impact of his general contributions. Okay, so Newton's going to incorporate the astronomy of Copernicus and Kepler with the physics of Galileo. Okay, so Copernicus and Kepler's astronomical findings, Galileo's physics findings, and put together his own theory, and explaining that there is a certain order and design to the universe that God has created. Okay, in 1666, he had a few conclusions. If you remember Newton and the apple tree, the apple kind of drops in front of him, and he realizes, hey, you know what? It doesn't really matter how far an object is from Earth, from the distance from where it drops from, because the power of gravity, the force of gravity, is much greater than just 5 feet, 10 feet, 20 feet. So he, questioned, why not as high as the moon, that even the moon is influenced by gravity as well. Okay, he's known to have worked with Gottfried Leibniz in inventing calculus. It's kind of debated, but he was part of the process. His book is really important, one of the most important scientific books ever written, called Principia. This was published in 1687. Had a lot of principles about natural laws and how physics works in describing motion and forces upon objects. Back then it was called mechanics. Physics was called mechanics, but now we just call it physics now. Okay, and he derived the universal law of gravitation. So by combining Kepler's law of planetary motion, right, confirming Copernicus's heliocentric theory, right, and Galileo's law of inertia of falling bodies, he established that the concept of gravity can be calculated into a mathematical law for universal gravitation, meaning that the pull of the Earth that we have in gravity, if I dropped, my water bottle like this, right, it's a universal force that is even, doing the same to all bodies in the solar system. So all planets, all moons, in the same way, it's the same force. And so in that case, he believes that all motion can be timed and measured according to the same mathematical formulas. You shouldn't need to use a mathematical formula for space and the larger bodies in outer space, or the ones that are just like an apple from a tree. Okay, so taking his law of gravitation and kind of putting it all together mathematically, right? He saw the world in a different way, and this is what we call the Newtonian universe, having a very mechanistic worldview, where he viewed the universe as a machine, and he understands that God has created it, God has designed it, and God has given these universal and natural laws that can be expressed in mathematical formulas, right? So God has designed it in a way we can figure it out, right? These natural laws are predictable, right? They're calculable, they are unchangeable, and because of that, God doesn't need to actively, constantly participate, because he just originally just kind of established how the laws are, and that's how nature is. And this is going to challenge a lot of medieval beliefs, because medieval thinking was that, hey, God is constantly in control, right? And that God is constantly like moving and having his will done as he pleases, not very hands off. So that's kind of how Newton saw. This view that Newton has, established is going to be the foundation going into the Enlightenment, where people are going to see more God is more hands off and not like the God that will constantly trying to work in your life, and that's going to be the idea of deism. Okay, so he doesn't believe that there are supernatural and miraculous forces that are playing, but God's role is essentially that he's just a clock maker. Once the clock is made, it just ticks and it just goes. And he just believes that gravity is the explanation of how things are moving, are dropped, right? But it doesn't explain who set things in motion. He still believes that God exists, right? God is governor of all things in this universe, but Newton's kind of worldview and his mechanistic concept of the universe is going to translate not just into enlightenment, but surpass that, going into even influencing Einstein in the early 20th century. Okay. All right, so just one thing to know, and I'll transition into this later on when we talk about religion, but most other scientists like Newton are going to continue to believe in God, just slowly lose their dependency on his divine power to do stuff. Okay. All right, so let's look about how did the scientific method come to be founded. New ideas in the universe had an impact on the Western views, and so these ideas are going to be looked at and founded through an established method that is derived from Descartes and Francis Bacon. Okay, so both are around the mid 1600s, and they both address the problem of knowledge. So they both had a lot of questions about this, and they asked, how is it possible to really know anything for certain? They really had this question, like, how do you really know that what you know? Confusing for some, but it's very interesting. And so they both generated a lot of doubt, and they felt that a lot of the old knowledge from the past, from the Middle Ages, was really uncertain, right? It's really worthless, because you don't know if they had sufficient means or accurate means to know if the information and knowledge that they have is reliable, if it's if it's truthful, if it's reality, and it's even useful to carry on for later on. So a lot of times we're going to say we're going to start all over again from this point on. Before this, medieval thinking was very much rationalistic and deductive. The thing is that the way that I kind of mentioned is that medieval thinkers, medieval scholasticism believes that they have certain definitions that they know is true. Okay, and knowledge is building off of those definitions, and they're saying that we can deduce further things, we can think about and rationalize further assumptions based upon these for sure definitions. Okay, however, what Descartes and Bacon are thinking is that, hey, that's really backwards. We shouldn't say, oh, this is true, and we can assume other things are true. But they're saying is that you are not starting with truth, but you should end with truth, right? So what you find in the end hopefully should be what is reality, what is true. And if you guys remember the scientific method, eventually after a hypothesis, then you can confirm whether or not it's true. So the idea is to introduce deductive and inductive thinking. Deductive thinking basically is you're having a very general observation, a general hypothesis, and eventually you'll come to a very specific truth. Inductive thinking is where you have very specific observations, about certainties that you can see for sure, and then eventually you will have a broader generalization of an established truth. Okay, so both felt that there needs to be a true method of knowledge, and so by really capturing what is the true way, the true methodology of gaining knowledge, then that would reveal, right, how nature really works. And at that point, if we could find out, if we can crack the code of how nature works, then they can control nature for good reasons. And so that's where they believe that if we establish a way to dominate nature, to control nature, then they can come up with inventions and use their wealth to create more inventions for a comfortable, safe, and dominant life. And that's what we call beginning a scientific civilization. Okay, to able to control nature for their own benefit. So let's talk about our first guy, Bacon. Just a little bit of background. He's going to reject Copernicus. He's going to reject Kepler. He's going to misunderstand Galileo just because, like you said, they don't know for sure if they can really accept all these things. So he believes that there should be a total reconstruction of the sciences, of the arts, and all knowledge. He did not doubt the ability to understand the world. He just felt that everyone has learned it in a very incorrect way, right? And so nothing can be really trusted. So he's going to use two things. One is going to be the empirical method. The other one is the inductive method. Just to go over each. The inductive reasoning, as I mentioned before, you have to start with very specific observations, okay? And then later you can have a general truth come out of this. The empirical method is using the inductive principles, but instead of starting at assumed truths like the medieval thinking was, you're going to go from more of a particular to a general and experiment, or perform observations, and from that will lead you to certain generalizations. Okay, so he formalized the method that Tycho Brahe and Galileo already did. They did plenty of experiments and observations. He's just putting it kind of down and saying this is what we should do, right? And that's what we call the empirical method. You need evidence, you need experimentation, you need observations. Okay, so he wanted a practical science versus a pure science because he says that science should benefit industry. It should be able to be generating wealth. It should be improving agriculture and even trade. And so by being able to conquer nature, as I said before, science can bring your country to the cutting edge. Technology can improve the lives of the people around them. Okay, and then we have Descartes. Descartes is known to be the father of modern philosophy. The reason why he's called the father is because they believe that he is the originator, the one to actually break away from scholasticism in the scholastic tradition. He did not want to accept the theological doctrines of the Roman Catholic Church, and he wanted to break away from that, and many people followed him after that. He saw the world in a very purely rational way, right? It's very mechanical, kind of like Newton in some ways, but they're going to have some disagreements, right? He wanted to believe that there's a possibility to have a absolute highest degree of certainty. So he's very much thinking as a philosopher, thinking as a scientist, and his emphasis is on objectivity, right? So what is objective, right? What is the truth, regardless of who you are, okay? And also using reason is the way that scientists should establish a methodology, right? You have to be objective, you have to use logic. If you don't do those things, you're not performing science, and that's what he held to, okay? Some of his contributions as a mathematician is that he's going to contribute in analytical geometry, and if you guys kind of have learned, I'm not sure if you're there yet, but in math analysis, you're going to learn about Cartesian coordinates, and that's plotting the location of objects on a 2D plane, okay? X, Y, and Z, 3D objects, 2D plane. All right. It's not a math class. Anyways, he wrote a book, 1637, Discourse on Method, and basically he says, you know what, let's dump what we've learned once before, right, and just begin as a fresh start, okay? The sources of truth are only in science, they're not in theology, they're not in humanities. All we care about is science, right? So science and math is all he lives and breathes. And so he began to start reflecting and thinking about his past. And you know what? He came to the conclusion in saying that I have a lot of doubts, right? And through his doubts and through his uncertainties, that's what he believes, that he knows what is true. Okay, so this philosophy of questioning and doubting, right, is going to go from the 17th century to the 20th century, questioning a lot, and that will kind of build off of his early findings. Okay, so he's going to be introducing and using deductive reasoning to prove its existence and saying, I know a few things for sure, okay, and what I can know is I know that I have my doubts. I know that I'm thinking at this point, and he says the quote, I think, therefore I am. So the only thing that he did not doubt was his existence. The only thing that he did not doubt was his ability to think. His ability to think even doubts. It's kind of confusing, but the certainty of his existence was based upon his doubts. And so he believed a few things about science, right? Science needs to continue to grow, starting from very clear and objective facts, and that in order to understand a process or understand something, right, a problem must go through many steps. It's a step-by-step logical deduction, sequential order in saying if this is true, then possibly this is true, then this is true. And that's how you can get to finally, right, from a general to more specific, kind of like when you guys do proofs in geometry, that's essentially deduction, okay? All right. Lastly, he contributes Cartesian dualism. He divided all existence into two realms. There's a spiritual and then there's a material, right? Material or physical, same thing. Basically, the spiritual can only be examined through deductive reasoning, through your logic, right? General to specific, right? And the material world, the physical world, can only be subject to experimental methods. And so performing experiments, performing observations, that's the only way. So spiritual means things of the mind, in the mental, and materials more in the physical, and that's the only way you can approach certainty and truth. Okay. All right. Let's talk about religion a little bit. So Spinoza is one of our main guys. He's going to be the one to introduce skepticism. Most scientists during the 17th and 18th centuries were still religious, as I mentioned with Newton. There wasn't really a conflict between scientific questions, scientific inquiry, and spirituality. However, the scientific revolution increased skepticism and a more secular attitude, and that's going to continue just to grow from this point on. So you have to see that turning point, that when the scientific revolution comes, right, skepticism is going to creep in. Secularism is going to creep in, right? Skeptical meaning, questioning. Secular means of no faith, right? Not believing in a God. And so, especially among the elites, the educated, they're going to think this way. Europeans are going to, from this point on, demand more and more empirical, tangible evidence to what to know is true. Okay, so let's jump into Spinoza. Just a little bit of background about him. He's a Jew, right? So his family is from Spain. His family is Jewish, but from the Spanish-Portuguese heritage. They would have to emigrate. They have to emigrate to Amsterdam because that is where there was religious freedom, right? So they're being persecuted because during the Spanish Inquisition, many Jews were forced to convert to Christianity, and they didn't want to do that, so they left, okay? So that's going to play an impact upon his idea of why religion is not important, okay? And so a couple of things of his ideas was that he came to the idea that God isn't the same God that everyone believes, right? His philosophy was that God does not have existence apart from the world. He is very much part of the world, but everything in the world was an aspect of God, right? The flower here is an aspect of God. This dog here is an aspect of God. This tree, right? This pig, right? Everything that you see, this building, it has an aspect of God in it. And so this philosophy is what we describe as pantheism, but other people saw it as atheism. Pantheism basically is that anything and multiple things are a God. And He actually rejects Descartes' idea of separating mind and matter. He believes all things are just one. He believes that God is the universe. God is made the universe, but he's part of every individual thing, and every object is an expression of the attributes of God, right? This flower shows the beauty of God. The sky shows the expanse and power of God, right? And there is no evil. So essentially, the way he sees his philosophy is that God is depersonalized and indifferent, and not this loving, intentional, personal God to you. Okay, a couple of things to make him significant is that he first was the one to say that you shouldn't have this thing called rational faith. There's no such thing as rational faith. They can't be alike. If you want to believe in God and you want to have faith, sure, right? If you want to be rational and philosophical, sure, do that. But you can't put them together. Don't try to put your rational view and your faith in one, because there's no way you can reconcile it. That's the way that he took it. He believes that philosophy is a rational way of thinking, but religion is more of a supernatural, and it's not rational, it's not logical, it doesn't make sense. And so he's going to have a lot of criticisms against the Bible, arguing that it was not written by God, it was not divinely inspired, but it's just written by just some humans. And he felt that Bible was just literature because you have a bunch of humans that interpret whatever they want to, and because they're written amongst different times and different areas of the world, that it couldn't be all from God. So that was his thoughts, right? So he's going to have a lot of critiques. His book, The Theological Political Treatise, is a critical essay on the Bible, and is saying that religion is only for the purpose of becoming pious, right? To be of a certain ethical and holy way, where reason is to discern truth, and they are separated in that sense. Okay, as you can tell, he's going to have a lot of flack and criticism coming from the Catholic Church. He's going to be criticized as an atheist at this point, but I'm pretty sure he's kind of okay with that. All right, last guy, okay? Pascal, really important. He's a French scientist. Just as a background, he claims himself to be a Jansenist, so he's against the Jesuits, right? One of his main goals was that he wanted to keep science and religion united into one. And so one thing to know is that maybe you remember him from middle school math and, I don't know, like math in high school, but he came up with a lot of different theories, right? So you have Pascal's theorem, and that was part of geometry. He also had the theory of probability in calculating the possibilities of things, right? And also Pascal's triangle, which was the calculation of exponential functions. All right, so he had a lot of mathematical contributions, but that's not what I want to focus on. Okay, I want to focus on his goal and his aim to reconcile faith and religion. Faith and reason. So, one of his books that he wrote is Pensées, which means thoughts. It's a literal translation from French. And his goal was to convert rationalists, logical thinkers, right, to Christianity by appealing to both reason and emotions. So he's kind of reconciling them again. He says that humans are frail and deceived by senses, and they're misled by reason and battered by emotion. So humans, okay, they can be easily swayed one way, right? Yet their nature, every man, okay, is involved in thinking. And so Christianity was a religion that he believed that led people to be very great, but also very vulnerable, right? People are very fallen because of their sin nature, but also very special. He believes that you should have the ability to reason, but also, look inside your heart for your emotion to know what is good, and to think about that. But his quote is, "Man is but a reed," right? Weakest in nature, so man is fallen, is very weak, incapable to do many things because of their sinful nature within them, but he is a thinking reed. So God has given humans a rational brain for a reason. One of his famous quotes is his famous wager, that he says that you should bet, okay, that God exists for your benefit. Okay, the reason why is because if you believe that God exists, and he does, right, you have the eternal reward of going to heaven. If you believe that God exists, but he doesn't really exist, what have you lost? A little bit of earthly pleasure. right? But his last few statements about his wager, his bet, is that if you don't believe that God exists and God does not exist, you have nothing to lose, right? You lost nothing. If you don't believe that God does not exist, but he actually does, then you have everything to lose, because what you should have received was an eternal reward to go to heaven, but you don't have that, so you should have believed that he does exist in the first place, okay? So, last but not least, his failure. He was unable to unite science and religion together. His desire was that, but he believes that faith is an essential step along with reason. God is experienced by the heart, not by reason. But from this point on, European society is going to drift farther apart, and it's going to go away from religion and towards secularization. Okay. All right. Last slide. So how is science spread from the scientific revolution? We talked about how university was a place of learning. They're going to establish chairs of science, so certain professors are going to be recognized for their achievements. Royalty and princes are going to become patrons, and so governments and monarchs are going to encourage scientific thinking to further the prestige of their country, and saying, hey, look at us, we've established and we have found and we've made these things, even though it's just a scientist, but they claim it as their own, and they want to be on the cutting edge of technology. New journals are going to be written and established and published, okay, and of course the new scientific societies first are going to start in Italy, but most importantly are the ones in England and France. And so here are the two. For England, for the scientific societies, what is it? Is it like a secret group? Well, no, it's just means where it's a community of international scientists where the scientists can communicate across different countries. You don't have to be bound to just that country, but they get to meet and network with one another. Okay. All right. So the English Royal Society is the most successful and the most prestigious, and established by Charles II. And then you have the French Royal Academy of Sciences, thanks to Louis XIV, Sun King, to establish that as well.